The world over, one measurement that remains universal is the measurement of time. For centuries, towns and cities kept their own time. Then, in 1884, at something called the International Meridian Conference, it was decided that all time would be based against Greenwich Mean Time.
Time's up there, deadbeat. Maybe a taste of these will rattle your chimes. Maybe it'll help you remember what time it really is, you two-timer.
No, not that kind of mean. Mean, in this instance, is a standard time all over the world based on what the time is at any given moment of day or night in a precise location, Greenwich, England. The line of longitude which runs through Greenwich is called the prime meridian. As we travel east from this line, the time of day becomes later. And when we travel west of the prime meridian, the time of day becomes earlier. Let me show you on the globe. The world is divided into 24 of these time zones that were created to coincide with the 24 hours in a day, the time it takes the Earth to complete one revolution on its axis. And each time zone represents 1 hour. So, when it's 11 a.m. here in Greenwich, England, it's only 6 a.m. clear over here in Orlando, Florida, because it's 1, 2, 3, 4, 5 time zones away. Once again, here is Greenwich, England, and the time it takes the Earth to rotate from here to here is 1 hour. In other words, if it's 4 a.m. here in Greenwich, England, then it's only 3 a.m. here. 1 hour is subtracted because we're traveling west of the prime meridian, and during every 24-hour period, the Earth revolves 360 degrees. So, time is actually the measure of change. And change in this instance means the Earth's movement on its axis through each degree of its 360-degree revolution. I hope that wasn't too confusing. Hello? Oh, hello, meter. Uh-huh. You say you think you understand, but you're not sure. Don't worry, meter. Whatever you didn't get, we'll cover a little later. And that goes for you, too. Now, let's look at the units that we use to measure time. Time is measured in seconds, minutes, hours, days, weeks, months, years, decades, centuries, and millennia. Let's begin with the smallest unit of time measurement and work our way up. A second is a very short period of time. Altogether, say 1001. Ready? 1001. And the length of time it took us to say 1001, approximately 1 second passed. In doing mathematical calculations using time, the abbreviation for second is S. To see how closely we estimate an actual minute, on your own, try looking at a clock and counting from 1001 to 1060. You can use an analog clock like this, or a digital clock like this. And a minute should have passed when you say 1060. For instance, 1001, 1002, 1003, 1058, 1059, 1060. So there are 60 seconds in a minute, and we can approximate how long that takes. The abbreviation for minute is MIN, and we use minutes a great deal. Usually your classes are 50 to 55 minutes in length, like the one we see here ending at 3 p.m. We record in minutes the amount of time it takes a runner to run a mile. The next unit of time is the hour, and there are 60 minutes in an hour, and most people work 8 hours out of each day. According to this clock, it is now 12 o'clock noon, when the large hand moves all the way around the clock, returning to 12, and the small hand is moved to the 1, an hour has passed. Each of the small markings on the clock represent minutes. Therefore, there are 60 of these marks around the face of the clock, each representing the 60 minutes in 1 hour. Sometimes it's necessary to change hours to minutes and seconds. For instance, feature-length movies are usually timed at somewhere between 90 and 120 minutes. So to change from larger units of time like the hour to minutes or seconds, we need to multiply. Let's say we wanted to know how many minutes were in 2 hours, 30 minutes. The first thing we would do is multiply the number of hours, 2, times the number of minutes in an hour, which is 60, and the product is 120, meaning there are 120 minutes in 2 hours. Now, all we need to do is add the remaining 30 minutes to this. So that means the sum is 150. There are 150 minutes in 2 hours, 30 minutes. Now, let's find out how many seconds that is. To do that, we simply multiply again by 60, because there are 60 seconds in 1 minute. So, 150 times 60 equals, wow, 9,000. There are 9,000 seconds in 2 hours, 30 minutes. That's a lot of seconds, isn't it? The next unit of measure is the day, and a day is equivalent to 24 hours. Again, let's look at our clock. Let's begin with 12 o'clock when the small hand on the clock, the hour hand, has made one 360-degree rotation and is back to 12 o'clock. This is half a day. When the hour hand has made one more 360-degree rotation for a total of 2 rotations, 1 day or 24 hours has passed. We divide days into AM and PM. From 1 second after midnight until 1 second before noon, we call this AM or morning hours. But from 1 second after 12 noon until 12 o'clock midnight, we call PM. That means that the first 12-hour rotation of the clock is morning or AM, and the second 12-hour rotation is PM or afternoon and evening. That means that the first 12-hour rotation of the clock is morning or AM, and the second 12-hour rotation is PM or afternoon and evening. Have you ever wondered where the expression midnight and midday comes from? On March 21st and September 22nd of each year, an equinox occurs. Equinox is a word we use to signify equal amounts of daylight and nighttime. So during the equinox, there are exactly 12 hours of daylight and 12 hours of darkness. They're equal. On each of these 2 days, daylight begins at 6 a.m. and evening begins at 6 p.m. 6 hours added to 6 p.m. brings us to 12 o'clock midnight, halfway or midway through the night. And that's why we call it midnight. And when we add 6 hours to 6 a.m. or daybreak, the time becomes 12 o'clock, and we are halfway or midway through the day. So we call this midday, or commonly referred to as noon. So, let's review what we've had so far. We have had 4 units of time. We've had seconds, minutes, hours, and days. We learned that there's 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and that brings us to our next unit. There are 7 days in a week, and there are 4.5 weeks or 30 days in a month. Hello? Oh, hello, Meter. It's my brother Meter again. You what? Yes, there are. He says he flipped through his calendar and he found out that not all months have 30 days. Some have more and one has less. What's that, Meter? Ah, so he's asking why I told you there are 30 days in a month. Well, Meter, I'll explain that to him right now. Thanks for calling. Bye. Meter's right. Not all months do have 30 days, but if you take the total number of days in a year, which is 365, and divide it by 12, the number of months in a year, the average comes out to be just a little more than 30. So that's why we say there are 30 days in a month. Now, let's look at the next unit of time, the year. Like we said, there are 12 months in a year, or 365 days. 10 of these years equals a decade. And every 100 years is called a century. And every 1,000 years is called a millennium. The year 2001 marked the beginning of a new millennium, as well as a new century. And people all over the world did special things to celebrate it. In London, they built this, the London Eye, which gives visitors a bird's eye view of this ancient city. Aren't you excited to be living in a new millennium? You know, people only get to do this every 1,000 years. Incidentally, all of these periods of time we've talked about have abbreviations, with the exception of day and millennium. Second is abbreviated as S. Minute is MIN. Hour is H. And day, as we said, has no abbreviation. Week is WK. Month is MO. And year is YR. And CEN is the abbreviation for century. Now it's time for some real-world applications. Let's see how well you can apply what you've learned. How about this one? The Atlanta Braves baseball team left Atlanta, Georgia for a game in San Francisco, California at 2 p.m. The flight lasted 3 hours, and the plane landed at 2 p.m. Is it possible to leave and arrive at the same time? I'll bet your first reaction is no. But let's think about this. Look at my map. Here's Atlanta, and here's San Francisco, California. See these time zones? Notice that in order to travel this distance, the team is passing through 1, 2, 3 time zones. Remember, each time zone west of where you begin is an hour earlier than where you are. This means that when the team left Atlanta, the time was only 11 a.m. in San Francisco. So when the team has traveled 3 hours, it will be 3 hours later in San Francisco. When 3 hours is added to 11 a.m., it becomes 2 p.m. Let's look at another example. A local doctor told his patient that his heart beats 72 times each minute. If this is true, how many times would your heart beat in a day? Which do you think would be a better estimate as to the number of times your heart beats in a day? Would it be A, 1,000, B, 10,000, C, 100,000, or D, 1 million? Interesting question. Let's work it out together using a calculator. We'll start by putting 72 into the calculator. That represents the number of times it beats in 1 minute. Now multiply by 60 to find the number of times it beats in an hour. It beats 4,320 times in an hour. Now, since there are 24 hours in a day, we now multiply by 24, and the product is 103,680. So, our answer is, that's right, C, 100,000. So as you can see, calculating problems dealing with time is something you can use every day, whether you're figuring out the number of times you can jump rope in a minute, or the length of the seasons of the year, or whether you'll be able to stay up long enough to watch your favorite TV show on a school night, or how long you can get your paper plane to fly. I hope you've enjoyed our look at time. And until next time, this is Miles McLeader, just passing time.